Okay, so this video is on carboxylic acids and this is in the higher unit 2. Again, you will have some National 5 recap and also some higher content that's a little bit further in. Okay, so National 5 recap then. So your carboxylic acids, you need to know from National 5, have a functional group called the carboxyl group, and it looks like this. So you've got a double bond O to an OH. Okay, general formula for your carboxylic acids are CnH2n plus 1 COOH, and you need to remember that yes, they are called acids and they do react like acids. So they all have a pH of less than 7 and react like other acids. So for example, you have salts produced, okay, and when you react carboxylic acid, the salt produced has an anoate ending. So for example, sodium hydroxide, butanoic acid produces, so you've got your sodium in the salt and you've got this part from your acid. So you've got sodium butanoate plus water. Remember, when you react an acid and an alkali together, you get salt and water. Here's your salt. Okay, so examples of your acids from National 5. As here we've got butanoic, propanoic and ethanoic acid. Okay, but so obviously got 4 carbons and you can see this functional group here at the end. Okay, so the COOH group, and remember it's called the carboxyl group. Propanoic acid has 3 carbons and again you've got this functional group at the end. And ethanoic acid, which you need to know is vinegar, yes, the one you put on your chips, has 2 carbons and it's got this functional group on the end carbon. Okay, so really important that your functional group always comes on the end, okay, because it wouldn't be able to exist in the middle of a chain. This is because it only has one spare bond in order to bond on to the other part of the chain. So if it was in the middle part of the chain, it wouldn't have an extra bond to go each side. Okay, so reactions then, again, National 5 recap, as you can see, you need to know your reactions and what they react with. So because carboxylic acids are obviously acids, they react the same as acids. Okay, they're just known to be a little weaker than the strong acids that you previously know, and the strong acids you know are HCl, hydrochloric acid, you've got H2SO4, which is sulfuric acid, and HNO3, which is nitric acid. Those are the 3 that you need to know from National 5. Okay, so they react the same, so acid and metal hydroxide, you get salt and water. Remember, your salt, if you're reacting a carboxylic acid, has an anoate ending. So for example, if you react ethanol, you get ethanoate. If you react propanoic acid, you get propanoate, octanoic acid, octanoate, and so on. Okay, so acid and metal oxide give you salt and water, and acid and metal carbonate give you salt, water, and carbon dioxide. Remember that carbon dioxide is coming out because you have put CO3 in your carbonate in. So what goes in must come out. Here is your carbon coming out the other side. Okay, so here is on to your higher part. Okay, so your properties of carboxylic acid are very similar to your alcohols. This is because they have the OH, the hydroxyl group, present on it also. Okay, although the overall functional group is the carboxyl, like that. Okay, it's important that you know that the OH group on this is basically, it allows the reactions to happen. Okay, so your OH, your hydroxyl group on here, allows hydrogen bonding to occur. Okay, and it also causes your carboxylic acid molecules to be polar. Again, just like the alcohols video, you have the difference in it. Oh, I've got it in here. You have the difference in electron negativity here. So you have a delta negative and delta positive, and this allows carboxylic acids, for example, to hydrogen bond to water. Okay, so here's your hydrogen bonding. It is a van der Waal. Okay, so carboxylic acids, they react similar to alcohols because of this hydroxyl group that's present. Okay, carboxylic acids can hydrogen bond due to this difference in electron negativity and due to the presence of the oxygen directly bonded to the hydrogen down here. Okay, because of this difference in electron negativity, your carboxylic acids are polar molecules. Okay, and because they're polar, remember, like dissolves like, so carboxylic acids are soluble and miscible in water because of this. Because water is polar, so polar dissolves polar, and because it's polar, it can interact with the water molecule like such.